Now in this problem we have a cube. The size of the cube is given, let's say is equal to 1 1. The coordinate systems basically of the cube. Now electric field has a components where it's given in terms of Ex is equal to, let's say it's 3x I vector, then Ey is equal to 5y j vector, and Ez is equal to 6z k vector. Okay, now we want to find electric flux through a cube at the site where x is equal to 1. So that means we have to find electric flux of that is passing through this area. Okay, so how can we find it? Now this electric field x, y, z can be given can be written down in terms of like this one. E electric field is equal 3x I vector plus 5y a j vector plus 6z a k vector. Okay, as an example. Now after that we can say that we have to find, okay, after that we know that by formula is electric field dot A, right? So what is our area now? Area is equal to what? Say if you know the area, let's say this is 1 and this is 1, then 1 times 1 will give you 1 meter squared. Okay, let's say you know that one. But what is the unit vector of this site? So unit vector of this site will be actually I vector, correct? So that means if that's the case, then you say that 3x I vector plus 5y j vector plus 6z k vector. Then after that you have to multiply to the area, which is 1 multiplied 1 I vector. Okay, in the dot product, I times I should give you 1, and I times j or I times k should give you a 0. Okay. What about the x? So we want to find electric field when x at the 1, right? So that means I times I gives you 1, so therefore the flux at x is equal to 1 is equal to the 3x. So I times I gives you 1, so okay, 3x. The rest of things will be a 0. Why? Because I times I dot j gives you 0, I dot k gives you 0. So now what about x here? For the x you have to again plug a distance where x was equal to 1. Okay, because we want to find electric flux when x is equal to 1. So therefore at the end you can say it's equal to 3. Okay, and the unit will be the Newton meter squared divided by column. Okay, and so on. Now you can also find what will the electric field that is passing let's say as this area. Okay, how can you find it? Electric flux that is passing at this area, and in this case y is equal to 1. Okay, again you use this one. So electric flux at y is equal to 1, then you can just, I will just make a shorten. So 5 times y is equal to 1 j vector. Okay, j vector, and then you have to multiply to the area of the j vector. Okay, the rest of things becomes 0. So area in our case 1 times 1 gives you 1 meter squared. At the end you can say that it's equal to 5 Newton meter squared over column. This is how we can solve such a problem.